Okay, so we're solving involving logs. So you got to understand logs. If you don't know how to rewrite, you wouldn't have any clue how to solve this. But I think you remember that it goes that to the power of that equals that. So 2/5 to the power of -2 is equal to 1 over x. Now there's fractions all over the place here. But before I clear my fractions, I personally would probably have done the squaring and the flipping. It's a reciprocal, it's a flip and squared. In either order, it doesn't matter. 2 squared is 4, 5 squared is 25, and then you flip it. So 25 over 4 equals 1 over x. Now, there is more than one way to do this, but my personal favorite is clear the fraction. I know there's other ways, but would you agree if I multiply by 4 and x on both sides, I'm clearing the denominators? Clears? Clear. And you might be like, you just cross-multiplied. Yep. But the thing is, clearing fractions always works, and cross-multiply gets misused so often. You know, because kids think, I'm just going to cross-multiply, and they think they can do it here. You can't cross-multiply here. Here, you just have to multiply across the top and the bottom. So I think the concept of cross-multiplying screws kids up to some extent, because you don't cross-multiply when you do that kind of a problem. So I think stick with clear the fractions. All right, so then I've got 25x equals 4. 25x equals 4, divide by 25, divide by 25, 4/25. Raise your hand if you had that one right. Cool. All right. Let's go to this one, and right away, I would do something that would make my life a lot easier. I think some of you would have done a rewrite here, and it made it make your life harder. I think we should make that into 3 to a power, because then it'll simplify down to just a number. It's got to be a negative power, you are correct. So let's rewrite it and see if that makes sense. Somebody said 3 to the -3rd. Let's see is this really got a 27 in it? Yeah, because 3 to the 3rd is 27. And then that negative makes it 1 over, so yup, that's it. I think you're thinking about doing a rewrite, and we're not, because it's faster the way we're doing it. Your rewrite is going to leave you with a complicated equation. So I would just change this to this, and then I know that this whole part here is equal to -3, and it doesn't get much simpler for an equation than just chopping out the whole log part and putting in -3. Then my final answer, oh wait, divide by 18, not -3. Divide by 18. And I personally think the best way to reduce is to go factor that and factor this so that that cancels that, -1/6. You can reduce it in your head, that's fine. Just trying to show my work. All right. So I think that you're going to find that the rest of this assignment just has more and more complicated ones. Let's just work through a few more. How do I get that solved? First thing, make it a little simpler. What could I add to both sides that makes life a little simpler? 6. Everybody add 6. If you're thinking, well, I wouldn't have known that I should do that, I would just say, PEMDAS. If you're doing complicated equations and you're solving them, look to add or subtract anything at the first. And then look to see if you could multiply or divide by anything. We can. What can we do now? Divide by 2. And now, well, I did my multiply and divide, my add, subtract. Now I might have to handle some kind of an exponent. Ooh, that's what we're going to do right now. We're going to make this into an exponential. That to the that equals that. Jack, how do I clear this 1/2 fraction? Yes. I'm going to say putting them to the power of 2, which will then make these multiply. Right. Is this the kind where you get 2 answers? Nope. I did not just take the square root on both sides. I squared both sides. And one of the things that's unique about this unit is that you can check your answers. If I wanted to be sure this was right, I go back and stick 24 in. And oh my gosh, I see why it's going to work. Because when I put 24 right there, that has a base of 25. And that's related to this 5 here. Because see, if this is 25 and this is 5, we could write the 5 as a 25 square root. I'm just showing you that if my new problem now, after sticking in the 24, comes out to this, it's just begging me to rewrite that 5 as a 25 to a power. So that would be 25, but the square root of 25. And then this whole part here is 1/2, and 1/2 times 2 is 1, and 1 minus 6 is -5. Cool. I made sure it was right. I double-checked it by sticking it in. Do you have to check them? Just check the ones that you really care about. And honestly, on a homework assignment, I probably, if I were a kid, I probably wouldn't care enough to check all of my homework assignment problems. But on the test, when I've only got 4 really important ones, I would check them. All right. Solve 2 different ways. I'll give you one better. We could solve it in 3 different ways. But just try one way. Let's get it one way. Rewriting is a good way. It's just not always the fastest way. So all of you right now can find a way. Now, there's 2 ways that I'm thinking of, and a third way that nobody's going to think of, but I'll show you. I'm starting by dividing by 3. That should be one of your ways to do this. And then I can rewrite it. Well, that seems super impossible, except that I can, if I'm really good at this, make that have a base of 2 and this have a base of 2. And once the bases are the same, the exponents are equal, and it's not that bad. So make the bases the same. That's one way. You probably are doing it some other way. Cool, do it the other way. But either way, one thing you'd really want to know is that the square root of 2 is like 2 to the 1/2 power. That means the same thing as the square root of 2. You know that, right? Square root of 2 means 2 to the 1/2. That might help. I'm going to pause for a second. Finding one answer is, even that's pretty hard, but the real challenge here is, could you think of 2 different ways you could have done this? And then maybe you can reflect on one of them is probably faster. You can always do it that way. You just got to show it. the square root of 2 here could be written as a 2 to the 1/2, and this 4 could be written as a 2 squared. And then this comes down, and it'd be 2/3 x right here. A reminder that that's 2 over 1, and when I multiply these, that becomes 4 over 3x equals the other power, which is 1/2. Clear the fractions out. The denominator is what makes it a fraction. So I'm going to times both sides by 2 and 3. Get used to clearing out fractions. It's the best way to go. That 3 cancels that 3. 8x equals, that 2 cancels that 2, 3. X equals 3/8. And of course, there's going to be somebody who says, I did it a different way and I got 3/8. Cool, you were supposed to do it 2 ways. Now, here's the other way that I think would have been faster. But did anybody get 3/8? Oh, a bunch of people, good. Here's what I think would have been faster. If you could have written that as a 4 to a power, I'm going to show you this completely different way we could have done it. The square root of 2 could be 4 to a power. Yep. That could have been 4, and I got to shrink it down to a 2, so that would be square root of 2. And that would just be, sorry, so that would be the square root of 4, which would be 2. Now, how do I get it to be the square root of that? You know, like that just makes 2, but I want it to be the square root of that. I put the square root of that. So this could have been 4 to the 1/4 power right here. And the cool thing then is then the problem reads this. Log base 4 of 4 to the 1/4 power equals 2x. And all of that would just be 1/4. Times it by 3 and you got your 3/4. And we jump right to this part of the problem, which is way faster. I'm just trying to get x alone, so I'm going to multiply both sides by 1/2. And x is alone. 3/8. Same answer. I know. A lot of you would have never been able to write that for that, so then don't do it that way. And then here's a third way you could have done it. Third way I would do it is graph this. Y equals 2x. Oh, that's just a steep line like this. And graph this. I don't know if I had a calculator I could graph it. Y equals that. And logs, you kind of know what logs look like. And wherever that log graph was, I can guarantee you this, they crossed at 3/8 because that is what the answer was. So you graph them and you see where they cross. Now, I'm not sure what this graph looked like, honestly. It could have been more like this, but maybe it's been flipped. I mean, it's such a weird looking graph. Okay, let's go to the next page. Do I care which series of steps you do? No, because I just showed you there's 2 ways to do these things. Sometimes there's 3 ways to do them, but you have to show your work. And I think no matter what way you're doing it, it's subtract 9 on the first one. Because of PEMDAS backwards, whenever you're solving equations, look and see if you could add or subtract something on both sides to make your life easier. And then I would look to see if you could multiply or divide by something on both sides to make your life easier. And it's only after you simplified it down a whole bunch that you think, I wonder if I should rewrite it. That's just 4. And this is probably that moment where you'd probably want to say, I can't add or subtract anything on both sides because this stuff in here is stuck in there. So to get that out, I think I'm going to go 2 to the 4th equals negative 10x plus 6. And again, I love that we're in a class that's high enough level that I can just say, oh, that's easy. 2 to the 4th is 16, and then it's just algebra. Solve it. You can solve that. All right, that's what today's problems are like. There is a couple more examples we should go through because we haven't done one of these in a long time. Could these be added together? Yeah, because they have the same base. Better remind you how to do that. Log base x of these get multiplied. 12 times 3, I might as well just multiply it. 12 times 3 is 36. No, it's not. Yeah, it is. Sorry. Okay. Equals 2. And then I go x squared equals 36. And then really easy mistake. Square root, absolute value of x. Square root of 36 is 6. And then this has two answers. X equals 6, x equals negative 6, and then you have to go, but wait, I can't put a negative here. So that answer is called an extraneous answer. Final answer is 6. Do you have to show that part? Yeah. Because you got two answers. This gives you two answers. X squared equals 36 has two answers. It's just that one of them is an extraneous answer. Okay. Feel like this is still pretty normal. I'm skipping it. So, time to get to your Schoology quiz. Everybody find the Schoology quiz that is posted for today. You're going to have a lot of time to work on it, so I don't feel too bad that it's a little longer than normal. Did you read number 1?
Log base 64 of x minus 7 equals 1/3.
Is the x minus 7 in the argument kind of like I did it? Excellent. Okay, so then it's a rewrite right off the bat. Martin, can you tell me what to the what equals what?
64.
Oh wait, there's two more.
To
64 to the...
the 1/3 equals x minus 7.
And then Leah Martin, take it over from there. Do you know what this one is in your head? 4, very good. Finish it, you're so close. 11 equals x. If I wanted to be sure I was right, I'd go back and stick 11 here and see what happened. 11 minus 7 is 4. That's weird. Oh, you know what you could do? Since that's 4, you could write it as a 64 to the power of 1/3. Do you agree that 64 to the 1/3 is 4? So do you get why then the bases would be the same? So the answer is 1/3. It all makes sense to me. I checked it. It worked. All right, there's number 1. Just 11. You have a bunch of time. I always set my Schoology quizzes to have 2 tries, but you get the answers after the first try. So to prevent kids from just putting crap answers in and finding out what the answers were, to just copy them in, I make you score the average of 2 tries. So try on the first time. Otherwise, if you get a 0, then you know all the answers. The best you can have is 50%, which kind of prevents kids from just cheating. So give it your best shot, and then you get the answers, and then if after that you want to try it again, you can. All right, that's all I got for you for today.